Good morning to all of you. My name is Chiranjeev Patnaik. I am from Bose Katak from mechanical department, and today in today's session we will see about additive manufacturing process. So before starting we will see what we will cover in this session. So we will cover what is additive manufacturing, what is the meaning of additive manufacturing, what is the functional principle, what is the advantages, disadvantages of additive manufacturing, where this additive manufacturing is basically used. So this all we will cover in today's session. So basically first we will start from manufacturing process. So there are two types of manufacturing process present there. First is conventional manufacturing and second is advanced manufacturing. So what is the meaning of conventional manufacturing? In conventional manufacturing we use three types of processes. First is this one is your zero process. So what will happen in zero process is that your object mass remain constant. So obviously in zero process what will happen, your object mass remain constant. For example, you know that casting and metal forming, these are the example of zero processes. Second come is your positive process. So what will be come in under positive process is that your object mass will increases. So obviously for example welding, obviously we will add some type of material to it. So obviously what happen, object mass will get increases. Now third one is your negative process. In negative process what will happen, in object mass will get decreases. Suppose we will do some type of machining operation. So what we will do, the material gets subtracted, that means the material from that will get subtracted. For example, metal cutting, in our object whatever excess marks or excess material we remove that, and whatever desired set we require or we acquire it. So these three types of processes are there in conventional machining. First one is zero process, second one is positive process, and third one is negative process. Now next slide. In the next slide you can see that there is a human robot, there is an cutter type shape, and there is a cycle shape. All these images are made of means the material used here is plastic material we have used here. Now in this image you can clearly see that there is a sharp type of contour is available here. You can clearly see that there is a sharp type of contour which is impossible to achieve in this type of conventional machining. Means if you want to achieve this sharp contour in conventional machining, it will be not possible. So for that, to achieve sharp contours, or sharp edges, we have to use additive manufacturing or advanced manufacturing process. Okay, so in the next slide it is written that advanced manufacturing, if you want to achieve sharp contour in fast manner with low cost, we can use advanced manufacturing. Okay, so for example in this image you can see that these sharp contours are not, means we cannot achieve these sharp contours by the conventional machining. So we have to use advanced machining or additive manufacturing. Okay, so in advanced manufacturing what we will do, we achieve the sharp contour in fast manner with low cost, we can use advanced manufacturing. So the term additive manufacturing, it is its other name is 3D printing, and we can call it as rapid prototyping. So three names are available here: additive manufacturing, other name is known as 3D printing, and the next term is known as rapid prototyping. Next slide. In additive manufacturing, what is the term additive manufacturing? From the additive manufacturing we know that we have to add some type of material to it, either in the manner of layer by layer. So obviously we will add material layer by layer. Okay, so let's see what is the definition of additive manufacturing. So from the additive manufacturing it is clearly written that refer to a process by which digital 3D design data is used to build up a component in layered manner by depositing material. So obviously what we will do, we will take a 3D printing. Obviously in additive manufacturing what we will do, we will create a 3D model okay, and deposited the material in layer by layer manner. Means after first layer is completed, then we will go to the second step, second layer is completed, then we will go to the third step, third layer is completed. This process is continuous when we will achieve our desired length. Okay. So, in second point it is written as, also known as 3D printing, rapid prototyping, or free form fabrication, or free form fabrication. So, additive manufacturing has three names, that is 3D printing, rapid prototyping, or free form fabrication. So, using this technology, 3D objects are produced by stacking layers of material one by one over the preceding layer of melted or partially melted materials. So, obviously in additive manufacturing two terms are very important, that is layered manner. Whatever material we will deposit, that will be in layer by layer manner. First, that the thing is very important, and the second thing is that thus by stacking layer of material one over another, means one layer is completed, then we will go to the second layer, then the second layer is completed, then we will go to the third layer. The layer will be what we will it will paste over one over another by the help of melted or partially melted material. In the next slide, as you know that 3D printing or additive manufacturing is the construction of three-dimensional object from a CAD model or digital 3D model. So, obviously you can see clearly visible that we have designed a CAD model, 3D design model. Okay. So, a CAD model allows someone to see a part in 3-dimensional, including any intricate feature that will be difficult to depict in 2-dimensional drawing. So, what will happen in this, we will create a CAD model either in AutoCAD or obviously SolidWorks, different types of CAD model we can use. We will create a CAD model. So, what will possible in 3D dimension is that 3D model is that we can visible that object from anywhere, means we can visible means we can see that object in from top view, front view, side view. Okay, any view we can observe that object, but whenever we create a 2D model, what we will do, we will imagine that object from top only. Okay, but in 3D model it will be possible to see that model in anywhere, means any direction we can see, either from the top, right, left or bottom, any direction we can see the model. Okay. So, whatever in 3D printing, whatever we do, we create a 3D model. After that we take a printout of it, means after creating the 3D model we take a printout of it, and that object will be visible from any direction, either from the top, left, right, any direction we can see it. Okay. The term 3D printing can refer to a variety of process in which material is deposited, joined or solidified under computer control, create a 3D object with material being added together, such as plastics, liquids or powder grain being fused together, typically layer by layer. So, obviously I will tell that if you design a 3D model, suppose this is a you can clearly visible that in this image what will happen, we have created a layer by layer, means obviously we will create a 3D model. After that what will happen, it's this image will start from bottom and it will go to the top level. Okay. So, obviously in 3D printing what will happen, the material is deposited, obviously first material is deposited, after that it gets solidified or joined layer by layer, in layer by layer manner it will be created. Obviously suppose this is a cartridges, in this material is present. So, after that when we give the print command, so what will happen, the layer means from the cartridges the layer will go to the bottom, it will create a first layer, after that it will go to the second layer, then third layer, until it will achieve its length, its total length. In this manner it will goes on continuously. Next slide. Next we have a modeling. 3D printable models may be created with a computer aided design package by via a 3D scanner or by a plain digital camera and a photo geometry software. So what will happen in this, if you want to means create a object or create a model, you have to create first a CAD model. CAD model you can use any software like AutoCAD, CATIA, ProE, anything, any software you can use. You can design that CAD model and take a printout of it. But there is another option is available in here is that scanner. Suppose I want to print out a model, so I want to take this means take that scanner out. By the help of this scanner I can scan the object and the object is scanned and I will get the model in 3D basis. So obviously there are two options are available. First is obviously scanner. We can use a scanner to print out the object, to scan the object and take the printout. And second thing is that we can create a CAD model either in CATIA, ProE or AutoCAD, whatever software we can use. We can create a model and after that we can send it to the 3D printing machine and 3D printing machine do a printout, take a printout of that model. Okay, so whatever modeling means modeling you can either do a CAD model you can create a model or you can just use the scanner to scan the object. Anything you can do here. There are two options are available. So in this image you can clearly visible that you can by the help of scanner you can scan the object and the object directly go into the computer. Okay, directly go into the computer and after that what will happen, we can take the printout of it. Okay, in 3D model, 3D design we can take a printout of it by the help of 3D printing machine or additive manufacturing. So in the next slide, CAD models can be saved in the stereolithography file format STL, a CAD file format for additive manufacturing that stores data based on triangulation of the surface of CAD model. So obviously what happen is that whenever we design a CAD model, after that what will happen, we will send to the 3D printing machine in the form of .stl file format. .stl file format means stereolithography. Whatever we design a model, we have to convert it into the STL format. You have heard about PDF format, DWT format. So obviously if you draw a CAD model in AutoCAD, so after that you means that file format is in DWG format. So 3D printing has also a file format that is .stl file format. So you can obviously you can whenever you can use a AutoCAD or AutoCAD software, that will be in DWG format. So you have to change that file format to STL format. After that the computer will understand or a 3D printer will understand whatever model you have created and according to that the object will be created. Okay, so CAD model can be saved in stereolithography file format, a CAD file format for additive manufacturing that store data based on triangulation of the surface of the CAD model. So obviously whatever model we will create, we will convert it into the .stl file format. Okay, after that what will happen, we have to take a printing. Before printing a 3D model from an STL file, it must first be examined for errors. Most CAD applications produce errors in output STL file of the following types. Means whenever suppose we have created an object in AutoCAD and there is a some type of error. Which type of error? Holes error, you have face normal, self intersection error, noise cells. So these types of error are present in the drawing. So you have to correct that first and after that you have to convert it into the STL file format. So you have to check your model whether there is some error is present or not. If it is right, it is correct, then you have to convert it into the .stl file format. Okay. After that what will happen, after correcting all this you can go for a printout, you can easily go for a printout. But if there is some type of error, then your object will not come good. Yeah, there will be some type of error will be produced in the printing process. Then once completed, the STL file need to be processed by a piece of software called a slicer. which converts the model into a series of thin layer, produce a G code file containing instructions tailored to a specific type of 3D printer. So obviously what will happen, after creating a model and convert it into the STL file format, we have to slice it layer by layer. Obviously what happen in 3D printing is that whenever we create a model, it will be created layer by layer. From bottom it will start up to the top. Suppose I have given a 10 mm of length, so it will start from bottom, first bottom, it will create a layer, after that it will go to the second step. So that will be the work of slicer. So total object will be converted in by the help of slicer. Slicer will convert into layers. After that when we press the print button, it will create a layer by layer formation. Then this G code file can then be printed with 3D printing client software, which load the G code and uses it to instruct the 3D printer during the 3D printing process. So obviously we have to convert it into the STL file format. After that, when we press the print button, what will happen? It will create layer by layer formation. Then the last step is known as finishing. Some printing techniques require internal support to be built for overhanging features during construction. This support must be mechanically removed or dissolved upon the completion of the plane. As you see that in the image, it is clearly visible. In this image you can clearly visible that there are three types of letter is available: Y, H and T. In Y there is no support is available, means we have not given any support to this 3D object. Okay, and you can clearly visible in H there is some type of support we have given in this H. Okay, and also in T also we have given some type of support. So this support we have to remove after the completion of your object have been completed. After the completion of the object, we have to remove the support system from this. After that your object is ready and you can ready to use that product. Or before that you have to remove the support which you have given during the machining process. So any support you have given, so you have to remove that support. Next is your additive manufacturing process. You can clearly see that this is a nozzle and it created by layer, means first layer is completed, then second layer is completed, then third layer is completed. We will see in a video very clearly. Now this is a printer jet. You can see there the material will be added layer by layer. Now you can see here the material is added layer by layer, means first layer is be completed, after that the second layer will be completed. In this video you can clearly visible that in from the nozzle we have given the material, plastic material in the sense, and you can clearly see that the first layer is completed, and after that what will happen, it will go to the second layer. You can see clearly here that it will be created layer by layer. So from the nozzle the material is impinged on the workpiece and it will be created in layer by layer manner. So you can clearly visible here that the nozzle has been created the model layer by layer, means after first layer is completed it will go to the second layer and then it will go to the third layer, and the means design is start from the bottom and it will go to the top. Okay. Now whenever you go to a printing, a print means whenever you take a printout, whenever we go to a shop and take a printout, or in home we take a printout, what will happen, we suppose we draw a circle here, we draw a circle in a computer by the help of mouse. So after completing a circle in a computer, I want to take a printout of this model. Okay, so what we'll do, we will give command to the CPU that I want this printout. After that, the CPU will give command to the cartridge present in the printer. We know that in printer there will be cartridge. So in the cartridge that there is some type of material present, means we can say that ink is a material, is a type of material. Okay, that will impinge on the paper. Obviously it will impinge of a paper and it will be created in thin layer, you understood, and after that we will get a printout. Okay, so obviously it will be, the cartridges will be move in x and y direction or in rotational direction. When means whatever your model is, in that direction the model will be created in your paper. Okay, so this is the 2D diagram, means obviously we can give the movement, the cartridges will move in x and y direction, and this model is a 2D model. Okay, now whenever we talk about additive manufacturing process or 3D printing, we clearly know that the object will be created in 3D model, means we are creating a 3D model. Okay, so what happen in 3D model, there will be additional one axis will be there, that will be z axis. Okay, perpendicular to this axis. So what will happen, it will created, means the in 2D diagram you can clearly see that there will be a thin layer is present. From the top you can see it will be a thin layer is present. After that, whenever you create this circle in 3D printing, what will happen, it will create a thin by thin layer. Thin by thin means first layer is completed, then it will go to second layer, then it go to the third layer, then it go to the fourth layer, until it will achieve its length. Okay, so in this manner we get a cylinder here. Okay, so obviously if you see this model in 3D printing, we create a 3D printing model, so obviously we will get a cylinder here. Okay, in 3D printing we will get a cylinder. So obviously whatever model in 3D printing, whatever model you create, you have to convert it into STL file format. After that